We're talking about solving polynomial equations by factoring as one of the ways that we can solve polynomials. And so if we look at our trinomial that we're given here, we notice that each one of these has an x term in it. And so we also know that our lead coefficients are all divisible by 4. So we can take a 4x out of each one of the terms. So that's left with x to the fourth minus 10x squared plus 9. And that's still equal to 0. And then we can see that it's in the quadratic form because our lead degree is twice our middle degree. And we have a constant that finishes up our trinomial there. So we bring down the 4x, and we know that we're going to have two binomials. And in order to get x to the fourth, we have an x squared and an x squared. And two numbers that multiply together to get us positive 9 and add to negative 10. So we know that that's going to be 9 and 1. And to add to negative 10, they both have to be negative. So there's our polynomials. And now we should be able to see that we have a difference of perfect squares both here and here. And so we can factor this again, and we get 4x. And we know that difference of perfect squares says we take the square root of x squared, which is x, and we take the square root of 1, which is 1, and then we have to use the conjugate pair, so we have a minus sign and a plus sign. And then we can do the same thing again here at the end, and we get the square root of x squared is x, and the square root of 9 is 3, and then we have to use the conjugate pair, so we have to have 1 minus and 1 plus. Now this is still equal to 0, and so we can still use the zero product property to figure out what our zeros are. And in this case, what would make this part be 0? What would make the 4x become 0? That would be 0. So x would be equal to 0. What would make this binomial 0? 1. What would make this binomial 0? Negative 1. That would be 3, and that would be negative 3. So our solutions for this are x is equal to negative 3, negative 1, 0, 1, and 3. Now we have 5 solutions here, 5 zeros. And when we look at our highest degree, we have 5 degrees, so we should expect that we would have 5 zeros. And so this is what our graph looks like. We see that we have a 0 at negative 3, we have a 0 at negative 1, a 0 at 0, 1, and 3. Now, this is an odd degree function, so we know that it's going to go in opposite direction. It's going to finish in opposite directions for its end behavior. And we know that we have a positive coefficient. So it's going to start at negative. It's going to start in the negative, and it's going to work its way across. As you can see, it goes up, and you can see that the x value continues to increase. Then it's going to come down over here, and it'll cross. Keep working our way across to the 0, and then it keeps coming back up. And eventually our end behavior will continue all the way through.